Hello, everyone. Thank you for joining DataCon LA 2021. Welcome to Data Infrastructure and Security. My name is Hestia, and your host, and our co-host today is Idris. We will be moderating the chat and Q&A for you during the session. Today we have our guest, Francisco. He will be speaking about keeping pace with data infrastructure so it doesn't outrun you. Without further ado, I'll hand this over to Francisco.
Hi, everybody. I'm Francisco. I'm here to talk to you today about keeping pace with data infrastructure, a topic that I'm particularly passionate about, so that it doesn't outrun you. And I'll give a little bit of context about my background, some of the things that I've seen in my experience, and how the kind of space has really evolved. And then, if folks have questions and they'd like to jump in the chat or in the video, please feel free. I'd love to have this feel a little bit like a conversation if possible. But yeah, let's get started. So as I mentioned, I'm Francisco. I'm a tech lead for data engineering and machine learning here at FAST. We're at one-click checkout for the internet. I've spent the last 10 plus years working in data science, data engineering, and technology to launch and scale digital products. Some of those have been at large financial institutions like Goldman Sachs, the Commonwealth Bank of Australia, and AIG. Others have been in more marketing spaces, and even did a little bit of a stint in nonprofit. And my background academically is, I did my first master's in economics and statistics, and my second master's in data science and machine learning. I am very, very passionate about data and how it intersects with systems, computational statistics, and getting to learn from it. And so I find this space really fun, and just a great area where you can really learn a lot about the world and behaviors. And so that's kind of what drew me to this space, and why I'm so passionate about today. So to talk a little bit about, or to give you a heads up about what we're going to be talking about today, we're going to talk about four main topics. One, incorporating an Sdlc into data science. That's a software development lifecycle. Robust documentation that I think enables data democratization. And investing in tooling that helps you build, ship, and deploy data products faster. And then lastly, we want to leave some time at the end or throughout for folks to ask me some questions. Again, really, really would love to have this to be a little bit like a conversation. And so folks feel free to jump in and ask questions as much as you'd like. And so to give you a little bit of an introduction here, I mentioned that I spent the last 10 years in the space, and it's interesting to have that context because I came into this space when it was very much evolving on how we did analytics. 10 years ago, most folks were using production Oracle databases and having custom ETLs where they would pull it down or pull down data, put it in some data warehouse like a MySQL DB, use SAS to then transform, analyze, and process that data. And then over the course of 10 years, all of that shifted into using things like Hadoop and HDFS and having all these Parquet files. And then it shifted again into using Spark and managing a Spark cluster. And then now things are changing again, and you're seeing tools like Snowflake and other distributed systems that kind of make a lot of this distributed system storage and compute much easier to navigate. And so the reason I say all this is because all of this infrastructure has changed so much in the last 10 years, both from a computational perspective and from how you store the data. And they're so tightly coupled, and how you interact with both is so interesting, because before, one team would kind of do all that stuff, and now you've seen roles and engineers evolve and start to embed themselves in different parts of that process. And so then that leads me to the big question. It's like, how do you keep up with this when data science, data engineering, and machine learning engineering move faster than ever. And my suspicion is it will continue to move fast. And we just have to interact and try to accommodate for that. And I'll tell you a little bit about some of my experiences, how I approach that problem, and how we've tried to build that into what we do at Fast. So again, to give a little more context, Fast launched about 2 years ago. And in that short amount of time, we've written over 500,000 lines of code. We have 75 plus engineers and 25 plus data pipelines. And then I can't even tell you the amount of transformations that we have on top of that. And the reason that I, again, give this information is because given how fast we've scaled in just a short time, how do we manage all that complexity? Because there's a lot of data being generated. There's a lot of code being written. How do we deal with it, right? How do we keep up with it? And the big lead here is, as I mentioned before, a software development lifecycle. Having a software development lifecycle embedded into the data science work that we do enables us to actually move faster. And that's what I'm going to talk about. So why do we think about this Sdlc, right? It's about defining a North Star, right? You want to be thoughtful in the processes and the tools that you put together, how you architect and build and connect all of these systems together, whether that's the infrastructure you put in together for your real-time systems, and thinking about how that cascades into data engineering, having to extract that real-time data at some latency, and then thinking about how an end user, like a data analyst or a business analyst, uses that data is where we started from. That first principle of like, well, all of this data generation, this code, all of this needs to be governed with the right process. It doesn't have to be the most arduous process in the world, but it has to be a process that enables people to move quickly, but also have good guardrails so that they can't accidentally do something they didn't intend to. And so we think about all model development, all data pipeline as code. And so that thought makes you, or that framework makes you put a lot more intention about what you're putting together. You focus on readability, test coverage, standards that align with, engineering organization, quality, right? And we treat models as artifacts. We put unit tests into our creation of tables, and then we think about tightly coupling our backend real-time services I mentioned and our data pipelines, whether that be transformations or even the ingestion. And so with all of that, we started with the end game. We started with what we know we want and what that end state looks like, and then filling in an architecture that starts to bridge those gaps, right? Because you know where point A is, you know where point Z is, and you kind of have to fill in all of the other letters to enrich the system. But starting with that end game in mind, you can start to prioritize which pieces you're going to make some compromises in, and which pieces you can and have to be battle ready when you want to start launching some of these data products and big tools. And so we also treat our model development as code. Some folks might disagree with me on this, but one of the things I've realized is that whenever somebody's building a model, and maybe it's in a Jupyter notebook, or maybe it's an R script, that model doesn't get to production on its own. And so you have to think about how this model development is ultimately going to map into some real-time system or a batch system, because that will feed some real-time process. And so having that top of mind in all of the work that we do makes us a lot more rigorous in our standards about our model development, right? Thinking, again, how will this analysis that I'm doing map to the work I need to do in real time? And then thinking about models as versioned artifacts. Again, this is another contentious area for some folks, but models are ultimately just codified equations, right? Whether that's logistic regression, whether that's recommendation engine, whether it's k nearest neighbors or some other algorithm. Today, even a neural network, right? It is a static equation ultimately that is recomputing something or calculating something, which means it's code. And so when you look at it through that lens and think about how you manage the versioning, deployment, governance, and quality controls on that model, you're in a much better position to actually think about where the flaw is in that system, because you can start to test functionally those pieces. I can't tell you how many times at different organizations I've worked at, a mere zero in a denominator actually broke a prediction. And so having some of those thoughts top of mind really does help cascade into how your engineering best practices support the work that you're doing. There's an additional step in the software development lifecycle, which is that all models degrade. I've never built or deployed a model that didn't degrade. It's all models have a half-life. It's just about what that is for each individual one, and so it's important to monitor them, right? And you can have automated processes to recalibrate and deploy new ones, but it is important to be very, very thoughtful in this process, because whatever model you build, whether it's a recommendation engine or a propensity score, or whatever use case you might have, you have to be very top of mind of how do I measure this performance and make sure that I track it, because I will have to update it again. And so having that as a part of an engineering lifecycle really helps to focus on the measuring and building a strong pipeline there up front. And so now on to robust documentation to enable data democratization. So this is a little long-winded, but it's a topic that I'm probably the most passionate about, even though it isn't as exciting as some other folks might seem. And why am I so excited about it? Because transparency is important. Having a transparent system enables people to just go further and further into like the data rabbit hole, because as organizations scale, as teams of teams start to build tables or data models on top of data models, there's this lineage effect that you see, and having that transparency in the lineage allows people to understand where there might be a bug, or where there might be a modification, or maybe a change of process, or an opportunity to enhance something, right? Concretely, it can very much look like a production issue that was caught, and some business analyst finding it in some query later on, and going into the lineage of the data pipelines and saying like, oh, here's actually where I can trace this issue, and they could feed that back into the product team or into the engineering or your business, and then improve the quality, right? And this example has been consistent again at every organization I've worked at. In addition, from an organization perspective, it actually empowers people to be more self-serving and effective, where you actually just know how to get access to certain data and how it exists, which at certain large institutions, this might actually be a very challenging point, probably one of the most challenging points in data. But then the question is, well, how do you keep it transparent? How do you prevent some sort of data silo? And first, I'll define a data silo is, different organizations or large organizations having such bifurcated teams and processes and ultimately tables that they just don't know about the context of another team's data or another team's way of working. And so how do you prevent that? Again, by like creating a system that's transparent, so everybody can have that visibility. And also, having transparent communication about issues in data, right? Oftentimes people will what I call here optimize locally, which is they'll create one ad hoc script to fix something one time and run it and then move on. The problem with that is all of the context about that solution and what you just did is now lost, right? Somebody else who sees potentially some other weird thing in some data just might not know. And so the way to really improve the transparency and prevent some of these data silos is using tools that can be self-documented or that create documentation out of the box, which is, QDBT, data build tool, one of my favorite tools that we use here at Fast. And I'll talk us about some of the others. And so it's a good segue into investing in tools to help you build, ship, and deploy data products faster. And here are some of the listed tools, right? We use DBT, as I mentioned, Spark, as you can imagine, DynamoDB, Snowflake, GitHub, and we use GitHub Actions that really help us with lots of stuff, and CI/CD pipelines, and Snowflake, I think I mentioned that one. And then analytics platforms that separate code from compute and infrastructure. And so, these are some of ours, but there are many other alternatives. People use things like Airflow as well. And what I'll say is these tools help us really just go fast. And that's the North Star for our team, right? And for our org is to enable teams and teams of teams to move fast and ship data products quickly, right? And so how we choose to invest in the tools are at least for us personally, we think this makes sense, does it help me document something? Does it help me separate infrastructure, which is complicated on its own, from business logic? Because as I mentioned before, it used to be that like a data engineering and a data science team would handle all of the compute and the infra and provisioning their own databases and managing their own databases and managing all of the software that you use to actually execute whatever machine learning model that you're working on or that's popular. But what it turns out, if you separate that infrastructure from the actual code and the software used, you can move faster. You don't get people that are spending a lot of time on the wrong problem. And so that's a very impactful thing for us. Do we manage access controls from the tools that we're investing in a really good way to enable good privacy standards that we hold? Does it abstract complexity? And when I mean abstract complexity, I mean, does it make it easier for certain people, right? Like, not every query should be thousands of lines long, right? So if there's a tool that enables me to make a really long query into a very short one, that's high value, right? If there's a tool that enables me to spin up EC2 instances trivially without having to really care about everything under the sun for it, does that abstract complexity? Yes. And so we tend to prefer things that help do that. And again, in a governed, robust way. Does it help me deploy faster, right? Does it allow me to just, with high quality, make changes to my system? And then lastly, does it meet analysts and my team members where they are? And this is another high impact one as an organization. You have to understand where the context of the people that work in your teams and that are staffed for your folks, and make sure that it supports their skill set. Because if you invest in a tool that doesn't meet them where they are, that's a failure of the tool and the failure of the system that you put in place. And so we really, really care about that one is in supporting, empowering, and enabling people to be effective in their jobs. And so I'll leave you with some closing thoughts. One, code is code always. As I mentioned, whether it's building a model or building a pipeline or even a dashboard, there's usually code underlying that. So having some level of quality controls on that code is really, really high impact. Now, not everything needs to be treated as, production engineering, NASA grades, level of quality, but, you do want to make sure that you have the appropriate guardrails and checks and balances in place. And the other thought I'll leave you with is high value documentation is a lost cause. If it's not generated automatically from code, in my experience, this tends to be an area where people have good intentions and they update it, but sometimes that documentation gets stale, that person might leave, or the system can change, and even worse, it can actually tell people the wrong thing. And so if it's not auto-generated, and it's not a tool that's auto-generated, it can be very, very challenging for an organization to maintain this at a high bar. And then, make thoughtful architectural decisions. Again, the over the last 10 years, things have changed so much. And my suspicion is that they'll continue to change and evolve, and we'll start learning better and better things. So try to really make your bets as a leader about what's going to stay, right? I mean, we saw all different flavors of data processing stuff over the last 10 years, and it was almost no surprise to some that SQL still came out on top as a way to process data. It's been so for 60 years. And so it looks like that's kind of been the trend as well. And then solve problems with the intent of empowering self-service knowledge. Again, this is about democratizing the access to data, the usage of data, because that's how organizations differentiate, right? It's how they add value to their customers, their stakeholders, their users, is by being able to give them a great experience. And that only comes when you're able to learn from your data and learn from the experiences you're offering. And so that leaves us time for our Q&A. If there are any questions, I'd love to have folks talk.
Hi, Francisco. There are no questions at this point in time, so maybe we can hang out for about few minutes and see if folks have any questions.
Okay.
We have until 3:45 if anyone have any questions. I guess my questions for me would be, what's the future of data infrastructure that you believe that's going to be ahead? That's not in your slide.
So I mean, streaming data is the big thing that's becoming quite popular now, which is building infrastructure in which you can operate both in a batch way and a real-time way, right? It used to be very much the case that you would have to treat those two things as completely different engineering problems, where, and what I mean by that is you'll have some production database, right, that's serving data from a bunch of different REST APIs, and then you would pull that data that's in that production database into some data warehouse, right, and then you would do some analysis on that data warehouse, and you could use all sorts of different tools, right, to do that. Like maybe you'd park in a Postgres database or an HDFS database, or use PySpark or something weird, right? But now people are looking at, well, can I actually, not have to do all this sorts of things and structure with one solution that unifies it. So my suspicion is that eventually we'll get to a state where we're able to manage the complexity of both a real-time service and a batch service, and allow it to share code to operate on the two. We use Go as our primary language for our services at Fast, and it's very different than, and the libraries that people use are very different than what most folks use for traditional data science. And so there's a lot of complexity to maintain and be able to share that. It's just not quite as structured and similar. So my suspicion is that over the years to come, people will start to focus more and more on that and get more efficient on that sharing of logic between what I did in real time and what I did in batch. What that looks like in 10 years, I have no idea, right? I mean, I know, like, I can tell you that, like, what the same code I look like to write, some model and then something in real time that needs like really strict, like, millisecond latency. But it's all, I have no idea what it'll look like in the future. Because my suspicion is that, like, the solutions that exist today to do this aren't quite as, like, optimal as what people will inevitably want to get to. And so I think that's going to be like where things will change dramatically, if that makes sense.
It does.
So Francisco, I have a question. Do you have insights on where you're seeing the trends move from map-reduced jobs to Spark, right? With the streaming, you mentioned about streaming, and that's where we're also seeing a lot of the trends, and the whole aspect from data warehouse to data lake, and now with Databricks Lakehouse. How does this all fit in now? Because you don't want to do a lot of data movement. You want to do the real-time querying federation.
Right.
Where do you see that? I mean, with the whole machine learning and data science, where typical use case was for data lakes, right? They want data, they're trying to get that. Your thoughts on that would be really good, because I'm doing a talk on Sunday as well on our Couchbase analytics. I don't know if you've heard about Couchbase, but it's we're going to show some cool action integrating model with our databases as well.
Yes, that's a good question. I think one of the things that that I noticed over the past 10 years, right? Like, because I saw the start of data lakes.
Mm-hmm.
And then now some people are like saying, like, well, actually we didn't like that. It turned out it was a little bit noisy in some sense, because it's like it was almost too much data. We're just like, oh, nobody ever looks at this because they don't know what half the stuff is.
They call it data swamps.
Yeah, right. And some of that comes from just how your production data is stored, right? And understanding like what's actually reflective of your snapshot date, and like how
Mm-hmm.
something changed and how it's cascaded. So in some ways, like the old method of like just storing one Oracle database and like doing snapshot polls and like storing it somewhere was actually pretty good, because it like didn't create as much chaos as all these Parquet files and stuff to manage yourself. And so, but I guess what I'm trying to say is, I think there's going to be a balance where my suspicion is that I think there's going to be more of a balance between not having a data swamp, but having a data lake that you're quite intentional about,
Mm-hmm.
so that you can get kind of like the right amount of data, because sometimes it can you can send a complete team like off the rails, just searching through data, just never able to find the right
Yes.
one. And I
Yes.
I hate to say this, but like that I've had that happen at like a surprising number of large financial institutions, where it's just like, oh, hard to find the right table, right? And it's
Mm-hmm.
which is like a very surprising problem. But it, like, so that's why I think that might shift a little bit, but not too much too, so that like it's completely all lost, because there are lots of benefits by storing lots. It's just about that
The right balance,
spot.
right?
Yeah.
We are seeing a lot of the argument is on the TCO, the total cost of ownership, where you have a lot of data then sitting on like it could be on the cloud or private cloud, your own VPC.
Right.
But the movement of that, once the data is like a year old or 2 year old, they want to move it out to the cloud, to the data lakes, where it's more cheaper storage because of S3 and now
Right.
Google Cloud and Azure, they're all kind of trying to take that share. So we started seeing not only shifting the data, they want to then also do querying against the data. That's okay to have an impact on performance because it's okay because there's a latency aspect, there's a networking, there's a whole thing. So we're seeing more and more use cases where a lot of these customers are asking us as well as you've seen companies like or technologies like Presto, or we're also kind of doing this data streaming where they're in place. So that was my rationale of my question, and
Yeah, no, that's another good point, right? Where it's just like, how long do you, which I think moves more towards the SLA of the data needs that you have, right? Which is whether it needs to be fault tolerant, whether it needs to be backed up, whether it needs to be, queried and processed and analyzed in a low latency or
low
to some
latency, right?
latency, right? Yeah, because what was nice about HDFS and Hive was that, like, yeah, it was cheaper. People liked Spark because it was much faster, but then they found out that, like, wow, we have to pay for this now, and, and that was also the other learning from it too. It's like, oh, some things you can actually find a better balance for too. Yeah, and we had some queuing strategies at different institutions as well to kind of try to do that and define what was productive. But what I found is that no matter how big your Spark cluster is, someone's always overusing it.
Yeah,
so
you always over allocated the idle time, and it's like
yeah,
leverage, right?
yeah. And so
That's where things
those
like
those are
yeah,
yeah.
that's where things like auto scaling and optimizations on the clouds are becoming more and more because you're seeing bills coming from AWS is like, wait a second, you
Yes.
over allocated like 80% of I'm paying like hundreds of $1,000s of bills, so that is becoming a big area.
That's exactly right, and that's where, like, and my suspicion is that smart providers will try to do some of this out of the box, where they try to do some optimization and deprecate certain things if they see that the activity and usage is being lower. I mean, because if they charge too much, the long-term incentive to stay on that provider is getting.
Yeah.
But
so
like,
what we're going to show on our go ahead.
No, go ahead. Please.
Go ahead.
Oh
no,
yeah,
I don't want to interrupt.
In the SaaS world, you used to have to, like, manage all of those decisions yourself, and it's fascinating now. Like, yeah, I remember when I first started, we provisioned, I think it was 120 gig SaaS cluster is what we called it at the time, and then it's like wow, that's what we thought was big back in the days.
Yeah.
It's bonkers now. I mean, yeah, so it's very exciting how much this stuff has changed. It's just, who would have thought that people would just do this stuff? So cool.
Yeah. So I think I don't know. We have a few minutes left, but one of the things what we are doing is in capability. You might have heard about Couchbase, but what we're trying to do is we are bringing our personas of machine learning engineers and data scientists to be more closer to where the data lives, because we are based off of our analytics is based off on HTAP, hybrid transactional analytics processing, or HOPE, if you will, hybrid operational analytics processing. And what we're doing is we're not reinventing the rules of new libraries of machine learning. That we know where folks live in machine learning. They use Python, they use R probably. So we bring in bring in your Python models, right? You compile that, and you package it up and bring it to the database where data lives, and then you can run your predictive models or your data mining or your logistics regressions or your recommendation engines right as and when your data is coming in and your models is coming. So one challenge we have to think about as next step is, how do you operationalize it? Because the model, as you said, keeps on changing, right? I mean, let's say after 24 hours, the streams of data, that well-oiled machinery of integration is what we are working next, but we have done the baby steps of getting, and that's what we're going to demonstrate and we're going to show and share. So if you're interested on a Sunday afternoon at 4:00, if you're bored and if you have nothing else to do, probably you can join our session.
Yeah, that's great.
Greg, get your beer or something. It'll be fun.
No, that's great. This is an extremely hard problem, right? I mean,
yeah,
I remember the first model I built. It had to get we actually had to upload the coefficients into a database, and then it was apparently called with COBOL to actually do the execution.
COBOL? Did you say COBOL? Oh my God!
Yeah.
I remember days of COBOL.
Yeah, and so, but it was this model I trained in SAS or in R, retrained it in SAS, and it had like 500,000 coefficients, and we uploaded it to some SQL database, and then we pulled it in real time. We executed that stuff in COBOL, and so it was, but all that infrastructure has changed so dramatically. Now you have things like Databricks that expose models and Python APIs, and even R has it. So it's the world is gotten so different in such a cool way. And I mean, now like Google and people are making their own chips, right? So who knows what's going to be next?
With TensorFlow chips, right? Tensor chips, and I'll be more than happy if you don't mind if we can connect on LinkedIn and
of course.
Keep in touch. Maybe you can, if you're launching a new feature, maybe have you as a guest third person advisory to look at it and see, provide your independent opinion on some of the features which we launch.
Yeah, awesome.
Very
cool.
Right,
well, I think that's
nice to meet you.
Yeah, pleasure to meet you too.
We have about 4 more minutes.
Oh, we do? Okay. Yeah.
I will use this time to see if there is any other people that would like to have any questions. And if not, I would like to thank you, Francisco, for your presentation and the attendees for the questions and interactions during the session. You can contact the speaker directly. You can look up Francisco, Arceo. Francisco Javier Arceo. Is that how you pronounce your?
Yeah, that's right. That's right.
Awesome. You can look him up on LinkedIn, and part of our DataCon speakers. And if you don't have any other questions, please provide your feedback using the form provided on the chat box, which I will provide. Thank you again for everyone for joining today's presentation, and I hope you guys can gain some insights from the session. Have a wonderful day, and thank you for being part of this year's DataCon LA. Thank you, everyone.
Have a
Thank you, Francisco.
Happy Friday.
You too.
Bye-bye.
Thank you. Bye.